at example number 3. So this question is asked, what is the yield on percent of ethyne? That's ethyne is also called acetylene. When 50 grams of calcium carbide, molar mass 64. How did they get 64? Calcium is 40, carbon is 12. 12 times 2 is what? 24 plus 40, which will give you 64. Okay? Reacts with excess water to yield 13.5 grams of ethyne. And the molar mass of this ethyne is 26 points, or let's just say 26. Let's do 26, okay? How do we get 26? 12 times 2, 24. 1 times 2, 26. Plus 2 is 26, okay? So, the first thing is what? Write the equation for the reaction. So, for this equation, what is reacting is what? They said, what is the yield on percent of ethyne when 50 grams of calcium carbide react with excess water? So, you are reacting calcium carbide plus water. So this equation will give you ethyne plus something else there, which is likely to be calcium hydroxide. Okay, calcium hydroxide. So you balance the equation. If it's not balanced, you balance it. So from the equation, I think it's not balanced. So how do you balance it? You have to place 2 in front of the water. You have to place 2 here to balance the water. That's the hydrogen. And then the next thing to do is to, I think it's balanced like this, okay? Let's check if it is balanced. Calcium is 1, calcium is 1, okay? Carbon is 2, carbon is 2. It's balanced. Hydrogen is 4. This is 2 plus 2 here is 4. So we have 2 oxygen here. Then we have 2 oxygen here. It's balanced. So this equation is balanced. So the next thing now is to ask yourself, what are we looking for? We are looking for the percentage yield. Percentage yield. The percentage yield is actually given as the actual yield all over theoretical yield. That's the formula to get the percentage yield times 100 over 1. Now, but in this question, we don't even know which one is the actual yield and the theoretical yield. But quickly, let me give you an intel of what is actual yield. Actual yield, actually, this actual yield is the yield you get from the experiment when you carry out the experiment in the lab, or the product you get, or whatever you get from experiments. Okay, remember that what you get from experiments might not be the same thing with what you get from the theoretical aspect of it, that is from the calculation aspect of it, okay? Because there could be factors that could prevent that product to yield a good amount of the actual yield. There could be factors that we did not consider in the theoretical yield that could limit the production of the actual yield. So normally, actual yield is lesser than the theoretical yield. The values of actual yield are always lesser or somehow a little bit closer to the theoretical yield because of those factors when put into place can reduce the actual yield. Okay? So in most calculations, this actual yield will be given to you in the question. It's left for you to spot it out. So remember, we are looking for the percentage yield of this ethyne, C2H2. Now go back to the question. What is the yield on percent of ethyne when 50 grams of calcium carbide, which is the reactant, reacts with excess water, meaning that the calcium carbide is the limiting reactant, which will determine the product of the reaction. Okay? So 50 grams of calcium carbide react with excess water to yield, please watch, to yield 13.5 grams of ethyne. This 13.5 grams is the actual yield. This 13.5 grams is this value. Okay? So we are now going to use our knowledge of stoichiometry to get what it will likely to be. Remember, they gave you this. They said that 50 grams of this produce this. That's what they said. But on our own, we're going to resolve it and confirm if these 50 grams will actually produce this. If we solve it, whatever we get is our theoretical yield, which will now be somewhere here. So we now solve this and get the answer. It's quite a simple problem. It's just for you to apply the knowledge of stoichiometry. Understand the formula. Percentage yield is equal to actual yield over theoretical yield. Multiply with what? 100%. So the next thing now is for us to calculate the theoretical yield. Already I have told you what is the actual yield. Let's now find the theoretical yield from the calculation. How do we get the theoretical yield from the question? Remember that 50 grams of this guy of calcium carbide produced, we are looking for what is going to produce. So we're going to compare their stoichiometry. From their stoichiometry, from Stoich, we know that this mass will produce this mass. And what is the mass here? 40 plus 24 will give you 64, which is this 64 grams here. So it's going to be 64 grams of calcium carbide produced a time 26 grams of a time. Produce 26 grams of a time. If this is possible, then 50 grams of this same calcium carbide from the question will produce. How do we know what to produce? So it's going to be cross multiplied. So it's going to be 26 times 50 all over 64. So whatever you have here is the mass it's going to produce. So if you produce, the x value there will be 20.3 grams. It will be 20.31 grams. Okay? Now, this 20.31 grams is the mass of a time that is produced. But watch, in the question they told us that the mass produced is 13.5. But when we solved with the 50 they gave us here, we are getting 20.3. What it means is that the values are not the same. It shows that this one is the actual yield, because I told you before that actual yield is always less than the theoretical yield. Okay, the actual yield cannot be greater than theoretical yield. So the actual yield is 13.5. This is our theoretical yield, because we have already done it from theory. From theory of stoichiometry, we have been able to confirm that it is not 13.5 that we got here. What we got is 20.31 grams. So we are going to use these two now. If this is what was produced in the lab, experimentally, actual yield is what we got this. So the percentage of this guy inside this whole thing here will now give us the percentage yield. So how do we now get it? It's just to divide this over this times 100. So from the problem now, so we can say that percentage yield of a time is equal to the actual yield, which is what? 13.5 all over 20.31 times 100 over 1. So whatever we get here is the percentage yield. So the percentage yield is 66.46%. So this is the percentage yield of a time present in this production, in this question. So from the question now, you see that the percentage yield of a time is 6.46%. So with this percentage yield, industrialists or manufacturers can be able to know if the reaction is if you have a percentage yield of 66.646 of this guy, then it shows that yes, you are trying, but you have to improve. Look for something that will improve the actual yield. So because the more the actual yield is improved, then the better percentage yield, and the more the product or whatever you're doing, and the more profit the person makes. So this is important in the industry, in doing some calculations that will help them determine the percentage yield of their product, whether it is going up or going down.